Welcome back, dear students. Today is the second lesson of quadratics. In today's lesson, we will learn to solve a linear equation and a quadratic equation simultaneously, and we will understand the graphical interpretation of this solution we obtained. For that, I have taken two equations. The first one is linear, y is equal to 2x plus 4. Second one is quadratic, x square plus y square plus 4x is equal to 1. So let us learn the procedure step by step. First step will be, we will get the value of y from the linear equation. From this equation 1, we will get the value of y. That is, y will be on the left hand side of the equation and all other terms will be on the right hand side, and coefficient of y will be 1. This value of y we will put in equation number 2, quadratic equation, to get a quadratic equation in one variable, that is x. So instead of y, I am writing minus 2x minus 4 whole square plus 4x is equal to 1. Now I will simplify this equation after expanding the square. This is 5x square plus 20x plus 15 is equal to 0. We can further divide this equation by 5 and get the simplest form. X square plus 4x plus 3 is equal to 0. Now, this is quadratic equation in one variable x. Now, we can solve this quadratic equation by any one of the three methods which we learned. And I am solving this equation by splitting the middle term. And ultimately, I will get these two factors. So here I have two values of x, minus 1 and minus 3. This is step 2. In third step, first step was we found the value of y. Second step was we put this value in the quadratic equation and solve that equation to get two values of x. In the third step, we will use these two values of x to get two values of y. These two values of x will be put in the equation, linear equation, which we formed when we wrote y as an explicit function of x. Y is equal to minus 2x minus 4. For y is equal to minus 1, y will be, x is equal to minus 1, y will be 2 minus 4, which will give us minus 2. And for x is equal to minus 3, y will become minus 2 into minus 3 minus 4, which is equal to 6 minus 4. Y is equal to 2. And our solution to the system of equation is x minus 1, y minus 2 and x minus 3, y 2. You can understand that these are 2 points in the coordinate plane. This is their simultaneous solution. Algebraically, the values of x and y will satisfy both the equations. I hope this process is clear. Let me reiterate it. Step 1, we will find the value of y from the linear equation. Step 2, we will put this value of y in the quadratic equation to get a quadratic equation in x and simplify it to find two different values of x. These two values of x will be one by one put in the linear equation to get the corresponding value of y. So at the end, we get two different points which will satisfy both the equations. Now students, we will learn that the solution obtained by solving a linear and a quadratic equations simultaneously uh, it represents what in the graph and what is its importance. This will be extensively used in solving the exam based questions. For that, I have taken three different examples because there are three different cases. Case 1, the quadratic equation which we obtained after performing step 1 can have three different types of roots, as we learned in lesson number 1. These two roots can be real and different, as in this case. These two roots can be equal, and these two roots can be complex or imaginary. Let us see all these three cases one by one. Dear students, we will now learn the graphical interpretation of the solution obtained when we solve one linear equation and a quadratic equation simultaneously. For that, I have taken two equations. First one is x plus y is equal to 2, which is linear. Second one is y is equal to x square plus x plus 1, which is quadratic. Now, what was the first step in solving this system? We have to get the value of y from the linear equation. What was the second step? In the second step, we have to put this value of y in the quadratic equation to get a quadratic equation in one variable, which is x square plus 2x minus 1 is equal to 0. Now student, we have to see over here, a is equal to 1, b is equal to 2 and c is equal to minus 1. Discriminant is equal to b square minus 4 into a into c, which is equal to 8, which is positive. As we learned in last lecture, that if discriminant of a quadratic equation is positive, as is in this case, it will give us two real different values of x. And those two values in this case will be calculated by using quadratic formula. I am just putting the values of a, b, c in quadratic formula. As a result, I will get two different values of x. X is equal to minus 2 plus square root 8 over 2 plus minus. And this will be minus 1 plus minus square root 2. When I will put these values in the linear equation over here, y is equal to 2 minus x, y is equal to 2 minus x, then I will get y is equal to 2 minus 1 plus under root 2, which will give me 1 minus under root 2. And on the second hand, it will be y2 minus minus 1 minus under root 2. This is actually minus 1. So this will be 3 minus under root 2. If over here, this will be 3 plus under root 2. So what did we get? We got two values of two different points in the plane. In the first point, x was minus 1 plus under root 2 and corresponding value of y was 3 minus under root 2. Second point was x was minus 1 minus square root 2 and corresponding value of y was 3 plus square root of 2. So we got two different points on which these two lines intersect. This means that this line intersects the graph of the quadratic polynomial at two different points, as is obvious from the graph. So we conclude that in order for a line to intersect another curve at two different points, the discriminant of the quadratic equation obtained by during the solution process must be equal to greater than 0, must be greater than 0. So if discriminant of the quadratic equation obtained is greater than 0, this line will intersect this quadratic polynomial graph at two different points. This was the first case. Do remember that we are learning to solve a linear equation and a quadratic equation, and there are three different cases. Case 1 was a line intersects the parabolic curve at two different points. For that, discriminant of the quadratic equation obtained in single variable must be greater than 0. Now let us move to the second case. I have taken two different equations. This one is linear, as you can see. This one is quadratic. We perform step 1. Step 1 is already performed. Y is exclusively a function of x. In step 2, we will put this value of y in the quadratic equation, and ultimately we will obtain x square minus 2x plus 1. Over here, a is equal to 1, b is equal to minus 2, c is equal to 1, and discriminant will be b square minus 4 into a into c. This discriminant is 0. And if I solve this quadratic equation, these will be two factors. And you can see I will get two equal values of x, and ultimately y is equal to 3x means I will get the single value of y. So what is my solution over here? You can see our solution is 1, 3, single point. What does that mean? It means the line intersects the parabolic curve at only one point, which is 1, 3, and this is the condition. In order for a line to be tangent to a curve, the discriminant, tangent means intersects the curve or touches the curve at only one point. The discriminant of the quadratic equation obtained must be equal to 0. Must be equal to 0. So far we have gone through two different cases. The line intersects the curve at two different points. For that, the discriminant of the quadratic equation obtained during the process of solution is greater than 0. The line is tangent to the curve. For that, the discriminant of the quadratic equation obtained is equal to 0. What can be the third case? Obviously, third case can be like this. Line does not touch the curve. I have again taken two different equations. Let us go solve this equation. Y is explicitly written, so I will just put the value of y in the quadratic equation. First step is no more required. Then what I will do, I will solve this equation like this. From here I will get two values of x, but these two values are both imaginary. Negative square root of a negative number is not real. And ultimately we will get two imaginary values of y, and there will be no real solution. It means a line will not even touch the graph. This was the third case, and for that the discriminant must be negative. Discriminant over here is b square, b is 0, minus 4 into a into c, and this is equal to minus 8, which is negative. Discriminant is negative, implies there is no common point. So these three things will be extensively used when you will come across any past year question for quadratics. So let us precisely recall our today's lesson. In the today's lesson, we learned how to solve a linear and a quadratic equation. In the first step, there are three main steps. In the first step, we find the value of y explicitly. Then we put this value of y in the quadratic equation. We ultimately get a quadratic equation in one variable. we solve it to get the values of x, two values of x. Those two values can be real and different. They can be both real but same, and they can both be imaginary. In the second part of the lesson, we learned that in all these three cases, what is the graphical interpretation of the solution. I hope today's lecture would have been very beneficial for you. Thanks for watching. Please do subscribe this channel so that you are timely notified with the upcoming videos. Stay tuned. Allah Hafiz.